All right, today we're going to be looking at using the law of sines to find missing sides and angles of a non-right triangle. So the law of sines, like I just said, is something that can be used to find sides and angles of non-right triangles. Okay, so when you can't use the Pythagorean theorem, you can't use 30, 60, 90, you can't use 45, 45, 90, you can't is SOHCAHTOA, because you don't have a right triangle, this is when you use the law of sines. So the law of sines, before we get started, is a ratio. It's the sine of angle A over side A is equal to the sine of angle B over side B equal to the sine of C over side C. Okay, so all we have to do if I want to figure out what A, B, or C is I look at my triangle, decide what do I have and how can I plug it in, and then work with the equation to find the missing piece. So we're going to go ahead and get started. For the first two, it's just find each measurement indicated, round answers to the nearest tenth. So in problem 1, it asks us to find BC. Okay, what is BC? Well, BC it's not an angle. If it was asking for an angle, it would say measure of angle B, measure of angle C. But it doesn't. It says find capital B, capital C. What that means is, look at where B and C are. Here's B, here's C. BC means whatever's between them, and between them is that side. So what we're really looking for here is this side right there. So if you want to think of BC as anything, it's a side. This side corresponds to this angle A. The side across from it is always side A. So instead of X, we're going to call it side A. And we're just going to label our triangle fully. Here's side A, this is side C, and this is side B. Okay, just so we're aware. So in our example here, BC means find a little a. Okay, so we're going to find little a. So I'm going to look at what I have. I have my ratio. First off, I have the sine of angle A over side A equals the sine of B over side B, and it equals the sine of C over side C. So looking at this, I have to find little a, so I know I'm going to need that part of it. Little a has to come with angle A, so if I look, I have angle A, great. So this is going to be one of them, sine of 28 degrees over little a. I know I have to use that. Then if I look at my triangle, what I have left, I have B is 32 feet, but I don't know the angle B. I have C is 61 degrees, but I don't know side C. So I'm missing some pieces here. I kind of want to use this 32 feet because it's going to be easy for me to find angle B. If we remember, all triangles have 180 degrees in them. I know that two of my angles are 61 and 28. So if I subtract both of those, it's going to get me the measure of angle B. Okay, so 180 minus 61 minus 28. That's going to leave me with 91 degrees. So I can go ahead and write that in there. B is 91 degrees. Now I can use side B and angle B, and I can plug those in. So the sine of angle B is 91 degrees, and little b or side B is 32 feet. I'm not going to use C at all here. I do know that angle C is 61 degrees, like that says this, it says it right here. But it's not really helpful to me. Once I have A and B, I don't need to use C. I only need 2 out of the 3 pieces, and I have them. So what I'm going to do is just ignore this, because I have these 2. I have sine of A over A and sine of B over B. So what I'm going to do here is I'm going to solve for A. You have fractions on either side of an equal sign, so what's really easy to do is just cross multiply. So I have little a times the sine of 91 degrees equals 32 times the sine of 28 degrees. And to solve for a, I would need to move the sine of 91 by dividing it. I want to get it away from side A. So they cross out. And a equals 32 times the sine of 28 degrees divided by the sine of 91 degrees. And you can put this all in your calculator. So 32 times the sine of 28. And then we're going to divide that by the sine of 91. And we're going to have side A equals 15.025. It asks us to round to the nearest tenth, so A equals 15.0 feet. Okay. Now we can do the same thing, the same process for number 2. It asks me to find the measure of angle T. So I'm looking for angle T. I don't know what it is. If I look at angle T, it corresponds to side little t. And if I notice, I have this angle R, and I have side R. So I can use those 2 pieces. Typically, like in the last problem, it would be the sine of A over A, the sine of B over B, the sine of C over C. And that's fine. We don't have A, B, and C, but what we can do is just plug it in basically in alphabetical order. So we'd have the sine of angle R over side R equals the sine of S over side S, but we're not going to use S at all. We're just going to jump to T. So the sine of T over T. And I'm just going to plug everything in and solve. So I have the sine of 84 degrees over 19 centimeters equals the sine of angle T over side T, which is 12. Again, I'm going to go ahead and just cross multiply. So I have 12 times the sine of 84 degrees equals 19 times the sine of T. I'm going to start by just dividing both sides by 19 to move it over. So I have 12 times the sine of 84 degrees divided by 19 equals the sine of angle T. Now, because I'm looking for an angle and I want to move this, I need to move this over here. I can't just divide. I have to take the inverse. So the inverse sine of this whole thing. So 12 times the sine of 84 degrees divided by 19 is going to equal T. So the inverse sine of all of that stuff is going to equal the measure of angle T. Again, you can pop this in your calculator. You want to take the inverse sine of 12 times the sine of 84 degrees divided by 19, and then close that last parenthesis. And we get that T equals 38.911 degrees. So T equals 38.9 degrees. Again, we're rounding to the nearest tenth. Last example here. It just says solve each triangle. So solve each triangle means to find everything that's not there. So find everything else. And then round to the nearest tenth. Okay, like we have been. So things that I need. I need the measure of angle B, the measure of angle A. I need to figure out what side A is. And that's gonna do it. So what I do have, I have C. I have both angle C and side C. So I can use that little ratio. The sine of angle C, so the sine of 83 degrees over 33 inches, because that's, oops, not A. This is side C. Okay. Now what I can do is, I'm going to find angle B first, because I have side B down here. So I can just set that up. So the sine of angle B over 13 degrees. And I can cross multiply and find B. To solve for B, I'm going to start by dividing both sides by 33. And I have 13 times the sine of 83 degrees divided by 33 equals the sine of B. Again, just like in that previous example, I need to get rid of this sine. I have to move this over here by taking the inverse. So inverse sine of that entire fraction, 13 times the sine of 83 degrees divided by 33 equals angle B. So I'm going to pop this in the calculator. Sine of 13 times the sine of 83 degrees divided by 33. And we find that angle B, the measure of angle B, is equal to 23.0 degrees. Okay, so I found angle B. I can cross that off the things I need to do. Now I need to find angle A. Well, finding the measure of angle A is actually going to be pretty straightforward. I know the entire triangle is 180 degrees. So if I subtract angle B, which I just found to be 23, and subtract angle C, it'll leave me with angle A. Okay, so I have 180 minus 23 minus 83, and that's going to leave me with the measure of angle A equaling 74 degrees. Okay, I'm going to go ahead and cross that off my list of things to do. The very last thing is I have to find side A. So what I'm going to do is I'm going to take this ratio, which I started with, my C's, so the sine of 83 degrees over 33, it's going to be equal to my A, so the sine of A over side A. Well, I know that angle A itself, we just found it, that's 74 degrees. So I'm just going to find side A by cross multiplying. Okay, and now what I'm going to do is divide both sides by the sine of 83. Those are going to cancel out. And A equals 33 times the sine of 74 divided by the sine of 83. And from that moment, you're just going to type it in the calculator. 33 times the sine of 74. And then I'm going to divide that by the sine of 83. And I get side A equals 31.95 feet. So I'm just going to go ahead and round up to 32.0 feet. That was my last thing to do. I am done. And that is how you solve non-right triangles using the law of sines.